Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today we're gonna discuss another questions. This is regarding polynomials. So this is the questions that have appeared in I don't know in university entrance exams. I think it appears in UI's CMAC UI's exams, maybe in 2010s, 2013, or maybe 2014. So maybe let's just get ahead with the questions. Okay, let's take a look on the questions. Okay, the questions state that we know the polynomial f(x) is divisible by x minus 1. By divisible, I mean that by divisible, the questions mean that f(x) when divided by x minus 1, it left no reminders. So the reminders is equal to 0. Okay. And then the derivative of f(x) when it's divided by the x minus 1, it will result a remainder equal to a squared. So if the derivative of the function are divided by x minus 1, then the remainder would be a squared. And based on the questions, if the limit of when x approaching 1 of f(x) divided x minus 1 is equal to 2a minus 1, then the value of a will be okay. I think you can pause the video if you want to give it a try first, and then if you have already have your solutions on your hand, then we're gonna discuss this. Okay, let's answer it. Okay, maybe I'll write this first. We need to answer it. Okay. Uh, the first thing first. The first things first is that we know that f(x) is divisible by x minus 1. So by using the Euclidean algorithm for divisions for polynomials, we know that a polynomial would be equal to, so if we have a polynomial f(x) divided by, let's just call the divisor is px, and then the quotients, the result of that polynomial would be hx, and then it would be the same as px times hx plus sx, which means that the polynomial would be equal to its divisor times its quotients plus its remainder, right? So you might have known these rules for a long time ago. Okay. Now, because we know that polynomial f(x) is uh, divisible by x minus 1, by using this theorems, by your algorithm, we know that f(x) times x minus 1 hx plus would be plus sx. Now, since it has no remainder, the sx will be equal to 0. So the sx term would cancel out. Okay. What we left is here. Now, if we substitute the value of equal to 1, x equal to 1, right? It would be f minus 1 equal to 0. This is the information that we know. Okay, we know that f1 is equal to 0. And then we know that f divided f prime x, the derivative of fx, when it divided by x minus 1, it would result, the remainder would be a square. Okay, then by using the same logics that we used previously, we know that f prime x is equal to px. We know that the divisor x minus 1 times hx. We have to note that this hx not the same with this previous hx. So let's just label it with different label, h prime x, for examples, plus the remainder, we know that it's a square. So we substitute the sx with a squared. And then substituting the value of 1, so f prime 1 would be a squared. So we know that at f prime 1 is equal to a squared. Now, these are the third in the second informations from the questions. Okay. Now, Uh, now now we're gonna use these informations to states to describe what really happening in these limits. Okay, so this is the core information actually from the question. So the question state that the limit of x approaching 1 of fx is divided by x minus 1 is equal to 2a minus 1, right? Now, we know that we can use some L'Hopital's here to uh, to solve these limits. Yeah, because we know that these are 0 divided by 0 form, right? So remember that if you want to use L'Hopital's rules to solve a limits questions, limit problems, the condition that it has to fulfill is that when you substitute the value of x equal to 1 for this particular problems, it have to be in an undeterminate form. Now we know that this is an undeterminate form because if we substitute the value of of x equal to 1, we know, right? We know that uh this would be f1 divided by 0. Now f1 is 0, right? So the 0 over 0. So this is undeterminate undeterminate form form. Okay. Now, since this is an undeterminate form, we can use the L'Hopital's here. So the limit. So we use some L'Hopital's here. I'll label this as L to symbolize that we use L'Hopital's here. So we derive the L'Hopital state that the uh, the L'Hopital said that if we have an undeterminate form, then we could see the derivative of we can derive, we can do some derivatives on to the denominator and the numerator. So if the numerator is being derived, then we get f prime x, right? Okay, don't forget the limit sign. The limit of x approaching when x approaching 1. Then we derive the numerator, which comes to be f prime x. And then the numerator, the numerator, if we derived it, we do some differentials on with the respect of x to the respect of x, then it would left as 1, and this have to be 2a minus 1. So even though we are using some L'Hopital's here, we're using the L'Hopital's rule, the result of the limit would still be the same, would remain the same results, okay? And this would be the limit of x approaching 1, right, of f prime x equal to 2a minus 1. Now, since f prime x is since what we left for the function is a function that has no that has no divisions on it, so we could just directly substituting the value of x equal to 1, right? Now this would be f prime 1 equal to 2a minus 1. Now since f prime 1 is a squared, so a squared would be 2a minus 1. Then do some simplifications. A is a squared minus 2a plus 1 equal to 0. Then this would be a squared minus 1 is equal to 0. Then a must be 1. So these are the answer to the questions. Okay. So A is equal to 1. So you can write in this column A equal to 1. Okay, I think that's all for today. Thank you for listening to my explanations. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.